Hello folks, and welcome back to the Lambda Show. While the last few episodes have been about functional programming, I'm going to change gears for a bit. Lately I've been getting more into compilers. I recently started working on a Kotlin compiler plugin with Arrow Meta. This project has been really fun for me on a number of levels to work on. I plan to continue working on this project, but it really gave me a taste into compilers that I can't ignore. To that end, I decided to make my own compiler. The compiler initially is going to be an attempt at a brand new implementation of the Kotlin programming language, but I'm going to actually extend it and bring certain features in from Scala as well. May bring some stuff in from Haskell too, but we'll see how that goes. In any case, I decided to go ahead and make a series of videos sort of journaling my whole process as I go down the road of compilers and build this thing out. There's a number of features I've decided to bring into this compiler. It's going to be a bit of a challenge, but I love challenges. So stay tuned with me over the next several episodes as I go about implementing my own compiler. You'll learn all about how compilers work, how to write your own lexer, your own parser, how to create an abstract syntax tree, populate that with the source code, how to do analysis on that source code after you've populated the tree. We'll have the certain topics like type checking, type resolution, and it should be rather interesting to see how we fit that in the context of functional programming, especially as we start to expand on the Kotlin language and the grammar and the syntax and begin to add more features. Things like Scala has four comprehensions, and we'll try to make that work inside of Kotlin with this new compiler. Now, one end goal of this compiler is to support both JVM and native. Currently, the compiler from JetBrains, they have a JVM and they also have a native compiler, and that's cool, but there's a number of issues around how the current Kotlin compiler works and does things that make it a little bit challenging to deal with when you're writing plugins, for example. So one of the things I wanted to focus on with this compiler is making a first-class plugin system where it's very, very easy to access all the phases of the compiler, have a nicely separated front-end, back-end, and middle layer to the compiler. And in order to best support JVM and native, as well as maybe possibly we'll do a JS implementation as well, or JS target for this implementation, we'll also focus on how to do proper IR, or intermediate representation, to extract different targets and compile bytecode or treat it as a transpiler, a number of different things. Finally, one of the things I wanted to do with the new compiler I'm working on is provide better metaprogramming support, not just at compile time via plugins, but I also wanted to support metaprogramming at a runtime level. So if you've ever seen Ruby, for example, Ruby has an amazing runtime metaprogramming system. Perhaps a little too amazing at times. You can do on-the-fly monkey patching, which is both cool and also scary, depending on what you do. But I really wanted to have that kind of power and flexibility at runtime with the Kotlin language, or whatever we end up calling this language, as I start with Kotlin and start to add on to it certain features from other languages as well that I like. So this runtime environment is going to be rather interesting, because the runtime environment, in addition to letting you modify things and reflect over things like you can do in Ruby, and do a lot of really cool monkey patching at runtime, we're also going to try to see if we can get some diagnostic tools built out. And what I mean by that is, if I wanted to extract the abstract syntax tree, for example, get a printout of what it looks like, we can do that in this new compiler, or we will be able to once we get that part finished. So that's not something you can as easily do currently with the Kotlin compiler. But what I really want to do is build that out as well for Kotlin, not just in a Lisp style, but also have the ability to generate visual tree representations. In addition to that, be able to take that output and reflect over that as well. You can feed that into some other programmer tool and do some kind of interesting things with that. So we'll explore and experiment with these concepts. Really, there's two key features that I want to have available with this compiler, in addition to making it a little easier to work with phases and build plugins for. Sort of demystify that whole process, which in my opinion is just way more complex than it needs to be at present. I also want to make sure that we have really good first-class functional programming support, a really good type system, and one that's easily modifiable. And in addition to that, really focus on the metaprogramming side of things, both compile time and runtime. So stay tuned with us as we go through that whole process and learn how to build a compiler together.